Happy Wednesday, everyone. Again, I'm sorry that I'm not here with you. I would love to have been. Ended up getting sick and don't feel amazing, but I don't feel terrible either. So hopefully I'll be back with you shortly. They said I could come back on Friday, but had already had plans to be away on Friday with my youth group on a trip. So it's looking more like it's going to be on Monday when I see you guys again. So it means you'll have to learn with videos over the next couple of days. So today actually will be the last lesson I teach you. Then we're going to do a review tomorrow, and then you'll have a quiz on Friday. Now, obviously, with me not being there, uh, I just want you to do your absolute best, and I think you'll do just fine. So, anyways, we'll talk about that more with tomorrow's video. All right, so I'm going to go ahead and get started on this homework since I'm not there with you to kind of go over it based on the questions that you have. I thought this way I would just go ahead and do all of them. In case you did have a question, it would get covered. So number one is real simple. You're just trying to find the experimental or empirical probability of spinning a red. Well, there were 5 out of the total here, which if you add all those up, that's 20. So 5 out of 20, which reduces to 1/4. 1/4. Okay, the next one, number 2. The experimental probability of spinning a red or a blue. Again, the red, there's 5 out of those 20. You're still just spinning it once. So that's why you have to use addition. Remember, or means add. Okay, whenever y'all see that in math. It's not multiple situations. It's a single situation. One time you're spinning it. They want to know what the probability that it's red or blue. So red, 5 out of 20. Blue is 7 out of 20. And again, there's no overlap. So when there's no overlap, I don't subtract anything. So if you use your calculator and you add those up, it simplifies down to 3/5. Okay, here's where things turn just a little bit. Number 3, it says choose a number that's greater than 5 or choose a number that's odd out of 1 through 10. Well, greater than 5 includes 6, 7, 8, 9, and 10. So that's 5 out of 10 possibilities. Plus an odd number. Well, how many odds are there? Well, you got 1, 3, 5, 7, and 9. So that's another 5 out of 10. However, I want you guys to notice something. Is there overlap? See, that's what that addition rule that we talked about included. When there was both those that were greater than 5 and odd, you had to deduct those. So if you look right here, 7 is in both categories. So is 9. It's greater than 5, but it's also odd. So you have to deduct the thing that was double counted. You have to subtract 2 out of 10. Okay, you added it twice, so you had to deduct it once. So that's kind of what happens here with these types. Now use your calculator from this point and allow it to simplify for you, and it will. It'll break it down. You got an 8 out of 11 chance. I'm sorry. Looking at the wrong problem. That didn't make sense at first. It's a 4 out of 5 chance. My fault. Number 4. And I'm not going to do this example like that every time because I think you guys should understand that. So basically, here's how we're going to look at it. Choosing an 8 or choosing a number less than 5. Okay, what's the probability of choosing an 8? Well, there's only one 8 out of those 10. What about less than 5? Okay, well, that's 4, 3, 2, 1. So there's 4 out of those 10. Now, is there a situation where an 8 is less than 5? Of course not. So there's no overlap. So I don't have to reduce anything. I don't have to deduct anything. Nothing got double counted. So 1 out of 10 plus 4 out of 10 technically is 5 out of 10, which reduces to 1/2. Remember, if nothing gets double counted, you don't have to deduct. Okay, a liter of 11 golden noodles contains 5 cream, 3 males, 2 females, and 6 black, 1 male, 5 females. If a puppy is chosen at random, okay, so you're picking out of 11. What's the probability that the puppy is black, or female. Okay, so start with black. How many are black? 6 out of 11. Plus, now let's just focus on the females. Well, there was 2 and 5, right? So the chance of me pulling out a female is 7 out of 11. Don't know why I put 10. But this time we have to subtract the number because was there one that was black and female? Right there was 5 of them, black and female. So it actually was in both categories, so it got double counted. So we have to subtract it back out. So it's 6 out of 11 plus 7 out of 11 minus 5 out of 11. So you have an 8 out of 11 chance of getting one that is black or a female. Okay, number 6. A card is drawn from a standard deck of 52 playing cards. What's the probability that it's black or a heart? Okay, well, black. Black is half the deck, right? Half the deck is black. Well, how about hearts? Well, only 13 out of 20 or 52 of them are hearts. So you got 1 out of 52, or you could have put 26 out of 52. Plus you have 13 out of 52. Do you have any that are both black and hearts? No, that's not overlap because hearts are red. So there's no way they're black. So it's simply 1/2 plus 13 out of 52, or some of you guys may have known that that's 1/4. 1/2 plus 13 out of 52, or 1/4, is 3 out of 4. A 3 out of 4 chance. Okay, for these last 3 problems or so, it's good to have all the data. So first of all, we know that Lincoln High School has 98 teachers. Of the 42 female teachers, okay, so right off the bat, I know that there are 42 female teachers. So if there are 42, how many male are there? 98 minus 42, 56. Okay, so of those 42 female, 8 teach math. So 8 are female math teachers. Female math teachers, 8. Now, if 8 of the 42 are, if 8 of the 42 female are math teachers, how many teach something other than math? What we would call non-math teachers. Well, 42 minus 8 is going to give me that number, and that's 34. Okay, now, the next piece of information it gives me is 1/7 of all the teachers teach math. So how do I find out 1/7 of the total teachers? Well, my total teachers is 98, right? So I can do 98 divided by 7. 98 divided by 7 is 14. 14 people are math teachers. Well, remember, there's 98 teachers. If 14 are math teachers, how many are not math teachers? 98 minus 14. That's 84. Now, didn't we say that 8 of those were female? So if 8 out of 14 math teachers are female, that means 6 are male. And if there are 56 male and 6 are math, there are 50 who are non-math. So those are all the numbers that you're going to need. So here we go. 8. What's the probability that a teacher is a woman? Okay, let's start with that one. Woman or female is a total of 42 out of 98. Or teaches math. Well, how many math teachers did we say we had? 14 out of 98. Now, did somebody get double counted? Sure. There were women who teach math. How many were women who teach math? 8. They were in both categories, and therefore they got double counted. So it's 42 out of 98 plus 14 out of 98 minus 8 over 98, which reduces to 24 out of 49. Number 9, what's the probability the teacher is a man? Okay, well, there were 56 male teachers out of 98 and do not teach math. All right, well, how many are non-math teachers? Bunch, right? 84. 84 don't teach math. Now, what are my overlaps? How many men do not teach math? Well, non-math male teachers are 50 of them. So those are the ones that got double counted. So it's 56 out of 98 plus 84 out of 98 minus 50 out of 98, which reduces to 45 out of 49. And the last one, what's the probability that a teacher is a man? Well, we just did that one, right? That's 56 out of 98. Or teaches math. Well, there are only 14 math teachers out of 98. But how many are men who teach math? Those got double counted. 6 of them got double counted. So therefore, we subtract them to get it back to where it needed to be, and that reduces down to 32 out of 49. So you have to think from the perspective of you add the probabilities, but then you subtract the overlap. And if you understand that, then yesterday's assignment was pretty simple. All right, so we are going to now move into conditional probability. So if you do not have those notes yet, which I'm sure you do, let's go ahead and get those out, and we'll get rolling on our notes for today. Conditional probability. It's a little trickier. I'm going to show you like what you would call like the book way to do it, and then I'm going to try to help you understand it more from a logical standpoint. So, given events A and B, conditional probability is the probability of event B occurring, knowing that event A has already occurred. So the notation would be the probability of B given A. The probability of B given A. So here's the formula for it. The probability of B given A will equal the probability of B and A. Remember, and means multiply over the probability of A. Okay? So, your probability of A is actually going to be in the numerator in both of them. So with that being the case, there is a very logical way to go about it. Because if probability of A is in the numerator and in the denominator, what's going to happen to it essentially? Well, it's gonna be canceled out. So let's look at it from both perspectives. I want to show you basically the rule of doing it, and then we'll go from there. Number one, Mitchell drew a card from a standard deck of playing cards. What's the probability that he drew a queen, given that the card was red? Okay, so look, we're finding the probability that he drew a queen, given that it was red. So what probability is going to be in both the numerator and the denominator? The given that, right? Given that the card was red. Well, how many are red in a standard deck of cards? 26 out of 52. So 26 out of 52 is going to be in both the numerator and the denominator. Now, the only other probability that I need to know is how many cards are queens? Well, remember there's a queen in every suit, right? How many suits are there? 4. So there are 4 queens in that whole deck. Now look, just from a logical standpoint, what's going to happen when 26 out of 52 is in the numerator and in the denominator? Won't it cancel? So you end up with the answer 4 out of 52, which reduces, and it reduces down to 1 out of 13. That is the probability that you get a queen given that the card was red. Okay? Now, I want to look at it from another perspective real quick. And you're going to have to just kind of determine which way you like the best. So I like to focus on what's my given that. My given that is that it's red. So I start with this. How many cards in that standard deck are red? 26, right? Now, my focus only goes now to those 26 red cards. Of those 26 red cards, how many are actually queens? Well, you only have the queen of hearts and you have the queen of diamonds. Remember, the other two queens are not red. So you only have two out of those 26 red cards that are queens. See, I narrowed my focus. It's not all of it now, it's just those. So 2 out of 26 also reduces down to 1 out of 13. Same answer, different perspective. Okay, it's the same concept. It works the same way. Well, why would I ever do it the other way? Because a lot of times the numbers that we're trying to do are a little harder to narrow down. Like, for example, number 2. I think this is a really good example of when the other method is harder, and therefore I should use the first method. Let me explain. A number from 1 to 100 is randomly selected. What is the probability that it is a perfect square given that it is an odd number? So look, guys, we're trying to find the probability that it's a perfect square given that it's odd. So using my old method, using the method that's above, like the book method, what's my focus? What's going to be in the numerator and the denominator? The given that. It's odd. Well, y'all know in a group of numbers from 1 to 100, that's 100 numbers. How many you have to have that's odd? Half of that, right? 50 out of 100 are odd. So 50 out of 100 are going to be the ones that are in both spots. So really, my focus narrows down to, well, what's the probability out of those 100? Out of those 100, what's the probability that it's a perfect square? Well, think about it. 1 squared is 1. 2 squared is 4. 9, 16, 25, 36, 49, 64, 81, and 100. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of those 100 are perfect squares. Well, look, if these are going to cancel, then 10 out of 100 breaks down to 1 out of 10. Now, I want to show you my logical way of thinking. Here's how I did it. Again, we're trying to find the perfect squares that are odd. Now, how many odd ones do we have? We have 50. There are 50 odd numbers. Well, out of those 50 that are odd, how many are perfect squares? So if I've got my perfect squares over here, how many of them are odd? That one. Not this one. That one. Not that one. This one is odd. Not odd. That's odd. Not odd. That one's odd. Not odd. Only 1, 2, 3, 4, 5 of those 50 are perfect squares that the numbers were actually odd. So 5 out of 50, guess what that reduces down to? Same answer, 1 out of 10. So really, in a problem like that, I don't care which perspective you come at, you should be able to come up with the same percentage, or you should come up with the same probability either way, okay? I showed you both ways. You can choose from there, okay? Number 3, there are 62 people that take yoga class and 48 people that take spinning class. 15 people that take yoga also take spinning. If a person from these groups is selected at random, find the probability that he or she is taking yoga class if you know they take a spinning class. Okay, now in a situation like this, it's good to use these things we call them like a circle diagram. There's two different things that are being compared, and there's also an overlap. Okay, let me explain. You got two things here. You got yoga, right, and you got spinning. So 62 people take yoga. So that means 62 people fit in this huge circle, right? Whoops, I didn't mean to do that. 62 people fit in this huge circle. And then you got 48 people who spin, who fit in this big circle. But is there overlap? Does it tell me that there are some people who take both? Yeah, it says 15 people take both. So I've got 15 people right here in the middle. So how many people take yoga only? Well, if 62 people take yoga, but 15 are in both, the people who take yoga only are 62 minus 15, 47. How many people spin only? Well, there's 15 that do both, so 48 minus 15 is 33. All right, so let's go back to the question that's asked. It says, if a person from these groups are selected at random, find the probability that he or she is taking yoga. So probability that they take yoga if you know that they take a spinning class. So let's start with that bottom number. You know they take a spinning class. Guys, how many people do you know take a spinning class? Well, what did the instructions say? 48 people take a spinning class. So we're narrowing it down to the 48 people who take spinning class. Now, of those 48, how many are taking a yoga class as well? 15. So it's 15 out of 48, which if you type it in your calculator, that does reduce to 5 out of 16. I hope that makes sense. It makes a lot of sense in my brain. Number 4. Of the 30 students in Miss Smith's math class, 13 are athletes and 9 are in band. 3 of the athletes are also in band. If one student is chosen at random, find the probability that the student is in band if it is known that they are not an athlete. Okay, so let's do the circle again. What are the two things being compared? You got athletes and you got band. And I think the key number is how many people are in both? 3. So let's figure out my numbers. 13 are athletes. Yeah, but 3 were shared, right? So how many are athletes only? 10. And 9 are in the band. So how many are a band only? 6. Okay? So let's answer this question based on what it says. Find the probability that the student is in the band given that they are not an athlete. Not an athlete. So again, not an athlete means that I'm looking in what categories? Well, this one has a little trick to it. Because remember how many it said is in Miss Smith's class? It says there's 30. Well, 13 athletes and 9 are in band, but how much 13 plus 9 end up adding up to? Plus, it's not even that anyways, because remember, there's 3 that are overlapping. So let's just take what it says. If there are 30 students in the class and 13 are athletes, how many are not athletes? 17. Okay? Again, because even though I have certain categories drawn up here, 13 are athletes, there's 17 students that are not athletes based on the fact that there are 30 students in her class. So, of those non-athletes, how many are in the band? So non-athletes that are in the band would be 6. Okay? So 6 out of 17 actually will not reduce, and that is my number. Okay, so we're going to move on into two-way tables. These are a little bit easier because you can really kind of limit your numbers based on your condition. We're going to go to the back as well and do a couple more examples of those. But we're not actually going to do the frequencies today. We're actually not going to do frequencies at all. Okay, so once we get these two-way tables knocked out, we'll be in good shape. All right, so here you have two-way tables that basically are comparing a couple of different categories. So this first one is comparing people who prefer football versus hockey, but also boys versus girls. So again, the key is the given that. You see, this first one says, find the probability that they prefer football given they are girls. You see, I am only focused right here on the given that. It says given that they are girls. Well, how many are in the category of being girls? 6 plus 16. That's 22. 22 is my bottom number. Now, out of that group of girls, out of the group that I have highlighted, how many prefer football? Well, that's 6. So 6 out of 22. Now, will that reduce? Yeah, it reduces to 3 out of 11. That's how you do these two-way tables. It's really simple. You've got to focus first on your given that. Look at this one. What's the probability that it's a boy given that they prefer hockey? We're only looking across this category. So what's my bottom number? 10 plus 16 is 26. Now, of that I have highlighted, how many are boys? 10. So it's 10 out of 26, which reduces to 5 out of 13. Okay? So pretty simple, I think, right? Don't you guys agree? We'll keep on going. There are some that are a little bit harder. A, little harder. You don't see a given that, right? You don't see a given that. And that means we're not gonna limit. It says here, the table shows the result of 150 randomly selected middle school students who are asked if they take French or Spanish. So you got French, you got Spanish, you got 6th, 7th, and 8th graders. It says, what's the probability a 7th grader who takes French? Again, do you see a given that? You see no given that. So we're not narrowing down our category here. This is out of 150. Now, out of that 150, how many are 7th graders who take French? 25. So it's 25 out of 150. Sorry, it came out weird. 25 out of 150 reduces to 1 out of 6. Okay? If there's no given that, it doesn't narrow down our group. Look at B. What's the probability that it's an 8th grader given that they take Spanish? So again, what's my focus? Taking Spanish. So I am narrowing my field down to just this group. So my bottom number is going to include 23 plus 12 plus 33. That's 68. I'm only looking at 68 of these people. Now, of those 68, how many are 8th graders? 33. So 33 out of 68. You can type that in your calculator. I don't think that reduces. So 33 out of 68 is your answer. Look at the next one. What's the probability they take French given that they're a 6th grader? So what's my focus? 6th grader. I'm only looking across this category. 19 plus 23 is 42 people. That's my focus. Those 42 people. Now, of those 42 people, how many take French? 19. Again, I don't think 19 out of 42 reduces. That's my answer. Does that make sense? It's real simple. The next one says the probability of a 7th grader, given that they take French. So we're focused only on this category of people who take French. So add those up. That's 19 plus 25 plus 38. I think that's 82. Of those 82, how many are 7th graders? 25. 25 out of 82. I don't think that one simplifies either. So 25 out of 82 is my answer. See, given that narrows your focus. Since A did not have a given that, it didn't narrow my focus. Okay? Let's do one more problem, number 6, and then you can go at your homework. It says, what's the probability a junior that did not attend prom? That's good reading, Brad. So again, does it have a given that? No. So I am not narrowing down my field here. So I'm looking at this whole thing, okay? Well, they didn't tell me how many was actually polled here. So I just need to add them all up. So grab your calculator and just go 28 plus 97 plus 56 plus 19. I think that all adds to 200. So my bottom number on this particular problem is 200. So out of those 200, how many are juniors that did not attend prom? 56. So 56 out of 200. Will that reduce? Yeah, it reduces down to 7 out of 25. Okay? Now, next one. What's the probability they did not attend prom given that they were seniors? So my focus is seniors only. Okay, that's where I'm looking. My bottom number is my given that. So 97 plus 19, that's 116. Out of those 116, how many did not attend prom? 19. I don't think that one reduces, so there's my answer. Last one. What's the probability that it's a junior? Given that they attended prom. So they did attend prom. This is the category that I'm looking. The 28 plus the 97 is 125 people. Now, out of those 125 people who attended prom, how many are juniors? 28. So 28 out of 125. And there we have it. I don't think that one reduces. So, conditional probabilities. When they tell you a given that given that will narrow your search. It'll only, put into focus a certain group of your total. So here's the ones I want you guys to do on your homework, okay? Pay attention. I want you to do number 2 and 4 and 6. But I want you to do all of these, 7, 8, and 9. I want you to do number 10. And on the back, I want you to do all of these, 12, A, B, and C, and 13, A, B, C, and D. You don't have to do 14 because we're not going to do those frequencies. So that's what your homework assignment is, okay? So it's almost the whole thing, but it really won't even take you that long. So there you have it. I hope that you followed along. Again, I hope to be back with you guys Monday. I'm sure I will be because I started kind of turning the corner. I know I don't sound very good, but I feel a lot better than I did yesterday and the day before. So anyways, all right. Hope you have a good day.